on to sign 3.
Yeah, so about a decade ago, cloud giants found out that software controls are critical to make the underlying hardware networking infrastructure logically centralized. So our third sign is software controls. And before I hand it back to you, another quick poll. Which of the following factors is the primary motivation for your organization in considering or implementing SDN in the data center? Please select all that apply. To bring more visibility to your environment, to lower CapEx costs, you need a network that's more automated and programmable to support private cloud, or to improve security policy management in the data center. So IDC Research also asked the same poll recently to their audience, and they found that the leading factor for deploying SDN in the data center was to make the network more automated and programmable to better support private cloud. Let's see what our audience has said. Okay, that's in line with what IDC found as well. Prashant, back over to you to jump into software controls.
Excellent. Software controls is super important because, as the poll has indicated, it brings simplicity and automation. And we'll talk about those specific items in the next, this sign and the next sign. What happens today? Today we have a box-by-box network, very complex to manage. Sometimes, it is a central management entity is leveraged to manage these devices. What we have seen in networking over the last 20 years is that anytime you have centralized network management, it also impacts the overall scale. And typically it's after the fact, so limited in features, and also lags when new releases come out in terms of its support for features. So what has our cloud giants done? If you look at Google's Project Jupyter, really they're focused on open networking based on merchant silicon. They've leveraged class topology, class fabric, leaf-spine fabric. And finally, third important component here is leveraged hierarchical control plane, specifically an externalized controller that implements an important aspect of the control plane, and in the form of an SDN controller. And so what does a topology look like? So there are really two options in the way software controls are deployed. And there is there has been historically a ton of confusion in terms of what software controls are and what software-defined networking is. And so we wanted to highlight the two important aspects of it. Also, it's important to note that what we are discussing here is primarily physical networking, and SDN also has implications in regards to overlay networking, and that's not the topic here. Here we are focused on really physical networks. So applying software controls to physical networks, there are two options. One, you can get partial benefits with a controller that focuses on externalizing policy management on operations. And certainly this gives a whole bunch of benefits. However, it is important to note that when a policy controller is deployed, the network control plane is not externalized. What do I mean by that? What I mean by that is that if we have a BGP running in the fabric, and let's say we have 100 switches in the fabric, then there will be 100 BGP instances. In other words, the control plane is fully distributed. Only the policy management and operations are centralized. Now, if you look at a more comprehensive software controls, then part of the network control plane is also externalized in the form of a network controller. So now you have a policy controller and a network controller. Often the two can be part of the same entity as a unified external software controller. In this case, the control plane is split. There is a part of control plane on the switches in terms of a thin operating system, and much of the control plane is externalized in the network controller. And so the benefit here additional benefit is really simplifying the actual fabric and forwarding plane. So now, if one has 100 switches in the fabric, there is only one BGP instance. This makes the fabric very responsive and easy to manage once a network control plane is externalized. So in both cases, we have hierarchical controls. Some controls are external and some controls are on the switches, but nonetheless, having a controller-based system is a very important aspect of network transformation. And so leveraging this cloud principle as first principle, Big Switch has applied this concept with an external controller across both its solutions, the switching fabric and the visibility fabric. And the entire solution leverages open networking hardware, cloth fabric, core and pod design, and it's controller based. So all of the science that we talked about are implemented as part of the Big Switch solution. Now, let's look at some of the management and operations challenges that need to be addressed with a externalized software controller. So let's look at installation complexities, right? Adding a switch, cabling checks, fabric formation, onboarding new switches, MLAC configurations with servers, server to leaf configurations. All of these are installation and change management complexities. Other operational complexities is looking at performance, congestion, drops, outages, upgrades. So all of that needs to be addressed, and this is where operations and policy and management controllers play a big role. And here are some of the examples of benefits that we see. For example, operating a Big Switch fabric, Big Cloud Fabric. If you add a switch, leaf or spine, it's a one-click operation. Just install, power up, cable, and walk away. There is no need to do anything when it comes to fabric formation. As switches are added, they form the leaf spine fabric, zero touch. Upgrading a large fabric of up to 140 switches, it's 3 clicks or 3 steps, and within 15 minutes. Multicast, 1 click to enable multicast, fabric-wide. And if you want to do any tracing across the fabric to check whether a source is able to connect to destination, all one has to do is simply do 1 click and get the entire trace on the fabric. So very easy to obtain speed and simplicity when software controls are deployed. Now, software controls have 2 benefits. One is operational simplification, and then the next one is automation, which is our fourth